Okay, so this is the material flow. Am I audible? And are you able to see the slide?
Yes, sir.
Okay. So this is the material flow where we are having this, MRP, MPS. This is a little bit more clarity, like what. Sorry, this is the same thing which Sigmund was asking. Yeah. Yes. Okay. So next is the planning process. This one we discuss where the input is coming from demand and from bill of material. Planning is done, and then based on which the purchase request is generated for purchase items, planned orders are generated for production items. Please take note, purchase requisition and planned orders are only the proposals coming from system. They are not the confirmed orders. They are not the firm orders. These are all only the proposals. But when you convert the purchase request to purchase order, it is becoming a firm order. Similarly, when you convert planned order to production order, it is becoming a firm order. Okay. So these things are committed, which are going to be executed. With the purchase requisition and planned order, we cannot execute anything in this discrete manufacturing. The planned order will be used in repetitive manufacturing. So let us not discuss it now. But in case of
Sir, sorry to disturb. Sometimes in the purchase requisition and planned order, we have a firmed indicator.
that is okay. That we will come to that later. Okay, that will come
Okay,
to that
sir.
later.
Thank you,
Okay,
sir.
I don't want to confuse those things and all. Right.
Okay,
So
sir.
that's a concept. Let us understand. Right. So purchase requisition is the proposal coming from system. Planned order is the proposal coming from system. Once we convert them into purchase order and then planned order convert to production order, they are becoming as a confirmed orders or firm orders to the system. So once we have these purchase order and production orders, those things will not be changed by MRP. Purchase order, production orders will not be changed by MRP. But the purchase requisition planned orders, as it is, which are created by system, they will be undergoing the change whenever we run MRP, if there is a change in demand or supply situation. For now, Kanimori has raised another point that we will discuss it later. Okay, that is another version of this one. Okay, that we will discuss later. But now, as it is, if a system is creating on purchase requisition and it is creating on planned order, let us assume we have not converted the purchase request to purchase order or planned order production order. So if there is a change in demand or if there is a change in some stock, then system will adjust this purchase request and planned order as per that particular situation. At the same time, if I convert the purchase request to purchase order, then planned order to production order, then the purchase order and production order are the thing which we converted. So system will not do any change in this. That is the difference between these. And purchase requisition and planned orders are only the proposals from system. We cannot execute anything from these two. But purchase order and production order are the orders which are getting executed. Where purchase order, we are sending it to the supplier and we do the goods receipt again purchase orders. Similarly, production orders are released to the shop floor. Production is executed against the production order. We receive the finished goods against production order, receive it to the stock. So like now purchase order, we receive the raw material or component into the stock. Production orders, we are getting the finished good into the stock. Now we are having the sales order, no? That is also going as input there for the planning purpose apart from the demand. Then based on the stock, we create the delivery and then we do the PG. PG is post goods issue and then we close the process. This is the planning process. So now let us discuss about the product structure, what we are going to discuss for this training purpose. So we are taking gearbox as an example for our demonstration, for our training purpose. We are taking one gearbox as an example. This gearbox, no, it is a gear motor. Actually, it is a gear motor. So there is a gearbox, there is a motor. There are two. So as a gear motor, this is one finished product. As a gear motor, this is one finished product. This is having two further finished product. One is the gearbox because I can sell the gearbox as it is. Then there is a motor that is also finished product. That is also we can sell as it is. So now for our structure, we're defining like this. So there is a gear motor as one product. To produce a gear motor, I need gearbox and motor. So motor I am purchasing from outside. Gearbox we are producing inside. To produce a gearbox, there are two again sub-assemblies. There is one input, there is one output. The input is the WIP or semi-finished product. Output is also WIP, which is semi-finished product. They have their own bill of material. That's what we'll be seeing here. So there is a gear motor. To produce a gear motor, we need a gearbox and motor, and also we need some component like fasteners. We need screws, nuts, bolts to combine this gearbox and motor. So this is the first level BOM here. And then to produce a gearbox, we need to have some input subassembly. We need some output subassembly. And there are some components required to combine these two input and output to produce a gearbox. And then the inputs are produced from some components, outputs are produced from some components. For our training purpose, I take this gear motor as an in-house production item. Gearbox, input, output, all these things are in-house production items. The components, which I assume some of the things are direct purchase, some of the thing as a subcontracting process. And the motor and other components, I treat them as a direct purchase. Like that, I just defined here. This is the product structure which you are going to see. Pictorially, this is what the product what we define. This is the inline helical gear motor, for example. This is FG. Here we are having this finished goods of gearbox, finished good of motor. These are the components. This finished good is produced from input subassembly and output subassembly, and other components are required there to assemble it. Input subassembly is having these components as bill of materials. Output subassembly is having these are the components. This is the pictorial representation of the bill of material, what we are taking for this training purpose. Is it clear, the product structure? Or if you have any doubt in this? Is this product structure clear? Or somebody is having any doubt?
You'll have to observe it. Conceptually, it is clear, Satya. But
Yeah,
I think
okay. Right. Conceptually only.
Yes, I have a question on this particular slide, sir.
Yeah.
So the inline helical input SFG, okay. It is looking at this particular the second SGMC. These are the parts that go for the inline helical input, correct?
These are the parts.
Okay. And for the output, it is the part that I'm. Yes. Okay, sir. Okay.
Anyhow,
SFG semi. Yeah. Okay, sir.
Yeah, tell me.
SFG semi-finished goods, right, sir? And FG is finished goods.
Yes. The FG is a finished good. SFG is semi-finished good.
Okay.
So is it clear, Mandar and Kani?
Yes, sir.
yes, sir.
Yeah. Okay. So now I refer these materials. These are all already there in the system. That's what yesterday, when Sigmund was opening the system, we were showing this. Now I think I hope some of you please open your system and keep it ready. I will ask you to share the system now. So these are the list of the materials we created in system. Like any material master codification should have some logic. Any metal master codification should have some logic. So here I am using the logic that because we are using SGMC as a company, right? So I put the SGMC hyphen TRNG means training. This is the master data. And for gear motor, I put GM 1001, gearbox GB 1001. MT means motor, IP means input, OP means output. Then these are all now components. CP 1001 up to CP 1016. This is serial number. CP means component. RM means raw material. Like this, I define the training codifications. Now, each of you will have your own codifications. Like no S001, S001, like this. This S01 means one person. For example, I will give this assignment, this allocation, no, who is S01, who is S02, I will allocate it and give it to you. Then you will have this as a reference. Then you will be creating this metal master in the system as we are progressing. As we are progressing, you will be creating the metal master in the system, step by step. And then you will be using that for all practices. When you are creating the metal masters, you will refer these materials TRNG, but don't change anything in this TRNG. Don't do any changes TRNG. Whatever you want to change, you please do it here. In the metal code, what I am assigning to you, for example, if I am assigning any S001 to Sigmund, Sigmund has to use only this S001. You should not disturb any other materials. Similarly, S002, if I assign to Bhagavati, for example, you should use only S002, not any other materials. Okay? Please keep this as the basic rule. I will share this list who has to follow what. But this is the basic list. This is what yesterday we were seeing in the system. Right? So this is the business process, business case discussion what we had for this training purpose. So now, is there any clarification on this point? Please let me know. Because I will introduce a metal master overview next. So far we completed the fundamentals. Now I am going to little deep into the subject, starting with metal master. So metal master is that starting with the type of materials. As we see in supply chain, right? That is why I refer to the supply chain processes. It is moving from raw material to components to semi-finished goods, right? These are the different material, how they are converted. Raw material is converted into components, components are converted to semi-finished goods, semi-finished are converted into finished goods. Apart from this, there are spares, production resource tools, consumables, packaging material. These things are used to manage the maintenance activities, to upkeep the machineries. So these materials are maintained related to the organization levels. For example, at the client level, metal master details maintained are valid for the whole enterprise. For example, the material number, that is the metal codification which I told, the material description, unit of measurement, metal group which assigned to the metal, all these things are common across the client. At the plant level, the data are valid only for the particular plant. For example, purchasing data, MRP data, forecasting data, work scheduling data. I gave example, right? The pen. If I take the pen, the metal code for pen or description or unit of measurement, those things are remaining the same for across the enterprise. But an individual plant, whether I am doing purchasing or in-house production, or whether what is the forecast I am doing for particular plant, or what is that, if it is in-house production, what is the work scheduling, those things are changing. Also at SORO location, if you define some masters, see, for each SORO location, you have to define the individual details. that is valid for the particular store location only. So we have to maintain the master data specific to store location. So if we maintain different store locations, we have to extend the metal also to all the different store locations. Right from master data, it is creating issue. So this is the first answer to segment the impact of additional store locations.
Yes, sir.
So now metal master, what are the views which are organization independent, dependent combinations? This is a presentation what we discussed earlier with a little bit different format. Organization independent views are basic data 1 and 2, classification, purchase order text. Organization dependent views are foreign trade, MRP 1 to 4, that is 1, 2, 3, 4, warehouse management 1, 2, advanced planning, quality management, purchasing, accounting, or scheduling, those kind of views, which are all organization dependent and also independent are sales org, sales plan details, and some store location views. So this is the chart. No, the same thing. No, it is presented in the chart format here, table format. So what are all the details covered in these different views? So if we take basic view, the details covered are like a material code, description, gross weight, net weight. Product hierarchy is used in some organizations. No, for example, 01 means it's a gearbox, 02 means inline. So 01, 02, like that. Now hierarchy. We are not going to cover hierarchy here, but that is used in some organizations. What are the dimensions of the product, or any drawings to be attached? Those things can be done. These things are related to product life cycle management, PLM. So we are not covering those things here. But they are covered in basic view because those things are not going to change. Classification is to classify the materials, categorize and group similar characteristic of materials. So if time permits, we will cover this classification later. Then sales. Sales is covering what is the delivering plan, what is the selling unit of measurement. This is what no Bhagwati was asking whether we can have different unit of measurement for sales and also production. Here we can maintain selling unit of measurement. Sale order text, what is the transportation group, loading group? These are used for transportation planning purpose. Coming to basic data, what I explained, no, they are there. Classification enable us to classify the materials with identical or similar characteristics and group them further. Classification used in many areas in SAP, like a product configuration, those kind of things. Sales views are maintained for materials that need to be sold, only for the materials which are sold, not for all the materials. These sales views. So here it cover from which plant it is delivered, sales unit of measure, taxes, conditions, all those things. Then purchase view is maintained for external procured items, where we define purchase unit of measure. Sales unit of measure may be different, purchase unit of measure may be different. In-house production unit of measurement may be different. So those things can be used and defined in system. And then purchasing groups, I mean, who is purchasing it? Purchasing group we discussed earlier, right? Purchasing group is a person who is executing this production, the buyers. Material group is used to group the materials with the similar attributes. This is coming from basic view. There are some details which will be flowing from the basic view to the different views. Purchase value key are defining like over delivery and under delivery tolerances, goods visit processing and batch management. So please note, we are not covering the batch management here. But once we complete the course, maybe I will prepare the course and publish in the YouTube. There you can follow the batch management and other. Some of the concepts I kept pending. So those things I'll be preparing later and publish them in the YouTube also. So purchasing we discussed, then MRP view and PPDS. MRP view, they define how to procure. I mean, before that, how to plan and how to procure the materials and how to control the material with the purchasing and production process. That is what is covered in MRP process. MRP is having the planning type, MRP controller, reorder point, lot size, procurement type, plan delivery time, safety stock, what is the planning strategy, availability check, those kind of things. Advanced planning and scheduling, it facilitates production planning and detailed scheduling to do the advanced capacity planning. It replaced the APO, which was earlier in SAP ERP. So whoever is doing this APO, you need to switch over from the APO. It's good that you are learning these common processes, the PP and MM. But still, it is better you learn the other concept like DDMRP, integrated business planning, those things. Because APO, when SAP is going to withdraw the support for APO, you know any idea, Kanimari? SAP is going to withdraw the support.
Earlier it was planned on 25, sir. Now it's pushed to 27.
27. Okay. So it is valid up to only 27.
Yes, sir. But most of them we are moving to, already I'm working in PPDS. We are moving to ePPDS from 26.
Okay. Right. Then we have the forecast views, which will be talking about the forecast parameters, forecast models. So we'll be discussing the forecast because we'll be using this for automatic reorder point planning. Then you have the work scheduling, where we'll define what is the production unit of measurement. Maybe production we may be doing in terms of number of pieces. But when we're selling them, we combine them and sell them as a pack, boxes. So production unit may be unit of pieces, but selling unit of measurement may be number of cartons. No? So production BOM will be defined. Again, we will produce what is the delivery tolerance, if there is any batch. And then storage location, where we define storage bin, temperature condition, shelf life data, storage period, those kind of things. Forecasting, work scheduling view. And here, if you know the forecasting property, we can select forecasting model. See, these things, no, we should know the subject there first. Because we need to have some understanding on how forecasting is working. Because there are different models like a cycle model, seasonal trend, or a trend method, or constant method like that. We can select which are all the models like this. Our system will select on its own. Also, what is the past period we have to take to work out this forecast? And what is the future it has to work? All these things we can select. We'll see them as an example. Work scheduling view will be defining under delivery, over delivery tolerances, production scheduler, production scheduling profile, which controls the several business functions. Also, production unit of measure. It is different from unit of measure. That is not basic unit of measure. That's what I told. The basic unit of measure is number of pieces. But when I produce, I want to produce in terms of kgs, or I want to produce in terms of number of boxes. Like these options are available. Also, production time in days. See, whatever the time which is coming here for production, in material master, they will be defined in terms of days only. Actually, the production time for the metal as per the routing may be 20 minutes or half an hour like that. But those things can be defined only in routing. But in metal master, we can define the production time only in terms of number of days. Okay, this is one major difference we need to understand.
Sir, one question, sir, and also can you just say me, when we maintain some times in master data, it does not obey the calendar what we define on the plant level. So can you just also tell us which takes the calendar, which doesn't take any calendar, take all working days? Is it possible, sir? For example, if we define plant delivery date in the master data, it will take the calendar, what we define in the plant level.
Correct.
Okay, sir. If we define operational lead time in, it's an example. There are so many places we can define. If we define operational lead time in the BOM level, it doesn't respect any calendar.
Okay.
Likewise, is it possible to say as which respect the calendar, which doesn't respect the calendar?
Okay.
Because for MRP calculation, it's must for us to define. We do it randomly when we take the calculation date. Then we say, okay, this is a planned delivery time which takes the calendar, and operation lead time which add to the planned delivery time doesn't take any calendar. So that's need to be explained, sir.
Okay.
Thank you, sir.
Just to have an understanding on this,
Yes, sir.
whatever are dependent on your plant activities, those things will consider your factory calendar working days. For example, you have Saturday to Sunday, 7 days defined in the factory calendar, out of which you declare Saturday and Sunday as holidays, for example. Now, whatever when you are doing inside the factory, those things, whatever the activities you're doing inside the factory, they should not consider Saturday and Sunday. So those are all taking the working days. These are called as a working days. Examples of working days are goods receipt processing time. You are defining goods receipt processing time in Metal Master. That is as per working days. If you take in-house production time, that is inside the production itself. So it will take also your working days. Your planned delivery lead time, which is coming from your supplier. You release the purchase order to the supplier today, that is external. So it will take the whole days. It will not consider a factory calendar. Because factory calendar is applicable to your factory. But planned delivery lead time is a lead time you agreed with your supplier. So it will not consider the factory calendar.
For example, sir, sorry to interrupt. So if the planned delivery lead time, if you say from the supplier is 10 days, would that 10 days be considering Saturday, Sunday, or just
No.
working days, sir?
If you're releasing on 1st of the month, then on 10th it has to be available. It will consider total 10 days, calendar days.
10 days. Okay.
So here you have to understand calendar days means all the days. Working days means removing the holidays like a Saturday, Sunday or any festival holidays. We'll see them, right? When you are seeing the proposals coming from system, how the planned order start date, finish date, and how the purchase equation when it is released. When you are seeing those, you will understand. Basically, for this coverage, these are the things.
Sir, I have another question. If you say with supplier, if we define a calendar, then the planned delivery time will take that calendar of supplier, right, sir?
Okay, that function as of now in SAP S4 it is not that. Probably it may be there in PPDS. I'm not sure about it.
Okay, sir.
But in S4 it is not there.
In PPDS, we define planned delivery date in purchase info record. We said 40 days. That 40 days will take the calendar from the factory. That is how we have today. It takes the calendar.
But
calendar
no,
means
sir,
what? Calendar means what?
Calendar we define to supplier.
No, again, that's what. No, when you are talking about the planning with the PPDS, that is different. Because I don't know PPDS. Okay. Without knowing PPDS, I cannot make the comment. But if it is a regular purchase info record, when you are supplying with the suppliers, when you define 40 days as the lead time, system will take for example, today we are on 9th. 40 days means system will take this up to 21st, what it is 22 days, plus the remaining 18 days, up to 18th August, metal has to come here. That is what system will take. It will not consider in between Saturday, Sundays and all for planned delivery lead time.
Yes, sir. Exactly.
It will take the all days. That is all calendar days it will take. That is what the definition for calendar days. Today I am on 9th. So up to 31st, I have 22 days. The remaining 18 days in August. So if I release order today, 40 days lead time is on 18th August, I should get the material. That is how it will work. Is it clear for you?
Yes, sir.
Right. So now Metal Master, we are also having quality views where we have to control these things, inspection and quality procurement key, and we are not covering quality here. But anyhow, when the metal is coming, it will be received in quality. There are quality inspection, many things are there. But once you go through this course, PP and MM, you will be learning quality management on your own for sure, because that is not so complicated if you know this PP and MM. Then accounting, you have the price control indicators and valuation class. We'll be touching those things. We'll be basically using them here because we need to do some accounting and also costing. We'll not go through the product costing, but we'll be filling some details there. I will explain some basic fields there. That's it. And then Metal Master, if we take, there is a plant data views like storage bin, temperature, shelf-life data, maximum storage period, other things. Under the quality management, we inspection types and quality procurement types, right? These are the fields.
Sir, excuse me, sir.
Yes.
Sorry, sir. So on the previous side, I know it's out of the scope of this training. So the quality procurement key, I keep getting this error when I create stock transfer orders, and there is another person I send the item number to. What actually is that quality procurement key? Just for layman's understanding, sir, that I know, because I get this error.
The Metal Master will see. Okay.
Okay, sir. Yeah.
Right. So quality management, it is having the so production items, inspection types, quality management, procurement key, and then accounting view as this is whatever we discussed there, right? So we saw that different types of materials and different Metal Master views, right? With that, the presentation on this Metal Master is completed as of now. So what is the next step? Next step is we'll be talking on Metal Master practice. Metal Master practice. Just a minute. Just a minute. Okay. I think it's better we cut this part, then we'll open the new part now, because I don't want to stop in between. Okay. So another 5 minutes, maybe this record will be recorded, then we'll come back. Give me 5 minutes, we'll come back.